Good morning, everyone. Welcome to this session around industrial digital transformation using AWS IoT Sitewise. My name is Sanjay Chopra. I'm the go-to-market lead for industrial analytics at AWS. And my colleague here is Thomas Cummins, and he is a solution architect in our partner organization. And today, we're going to cover a number of different topics around industrial digital transformation. We're going to talk about what is digital transformation in the industrial world, some of the requirements and asks that we're getting from customers. We'll talk about a case study with Coca-Cola Isacek, which is a Coca-Cola bottler in Turkey. We'll talk about a case study with them. And then we'll kind of dig deep into Sitewise, and Thomas will talk about Sitewise, some of the design patterns, some of the use cases, and the reference architectures. And then we'll leave you behind with some of the kind of resources that you can use to continue evaluating Sitewise and some of our other services as well. So industrial customers have been going through a digitization process over the last 30 years as compute, storage, and networking has started to become more and more accessible and cost-effective. But many of these systems have been very much in siloed systems like MESs, PLCs, and SCADA systems. And according to McKinsey, manufacturing industries only realize 20 to 30% of the value of their data. And by leveraging more and more of that data, they can actually start improving development costs by about 50% and reducing costs by 25% in operating their assets. Our customers are looking for a single pane of glass for their assets and their production lines. They want to understand in near real time what is happening and then being able to predict what's going to happen on their production line and their assets. Partners such as Hitachi are seeing 10 to 30% improvement in unplanned outages and 15 to 40% improvement in productivity by using more and more OT data in their analytics. And lately, they've been focusing on improving sustainability goals, such as reducing energy and water by leveraging more and more of this data. And we'll talk about this a little bit more. So what are some of the challenges that we're seeing in the industry that our customers are talking to us about? They're talking about the availability of visibility of insights in their operations. For example, plant systems provide you with alarms and alerts, but they're very much like the check engine light in your car. They tell you that something has happened, but it doesn't tell you if you can wait a day, a week, a month. It's a piece of information, but it's not very actionable. And we hear from customers that they diligently follow maintenance programs from their machine manufacturers, but they still have unplanned outages. And while they implement MES systems and they use those for production scheduling, they don't give them the insights to optimize their operations and their processes. And manufacturers are the largest users of energy in the world today. So they're continually looking at how do they reduce energy costs, reduce water costs, and also meet the sustainability goals of the countries that they operate in. And that's becoming more and more critical today. So for example, some of the kind of common asks that we see from our customers, they're looking for operation efficiency. They want to lower the cost of managing the assets, but also increase productivity. They want to implement quality management programs to improve inspection accuracy as well as reduce scrap rates by doing more anomaly detection on their production lines. They want to implement predictive maintenance programs. They want to understand initially the condition of the assets, and then based on that, they want to run AI/ML programs that help them make decisions such as, do I derate my plant? Do I shut down my plant? Can I get more time to understand how I can, plan my maintenance on a derated basis so I don't have to have unplanned outages? And by liberating your data, instead of adding more data, you can actually start getting some more and more of these insights. By using AWS IoT services such as Sitewise, you can now extract data from your multiple OT systems, understand the asset condition and health, and get insights such as overall equipment effectiveness from your production lines. And once you have that data up in the cloud, you can start taking advantage of AI and ML models, such as Lookout for equipment that provide anomaly detection across your asset data in near real time, as well as Lookout for Vision that allows you to monitor anomalies on your production line, thus avoiding sending poor quality products into your supply chain. So I want to talk to you about a customer that we've been working with who have really been kind of focused on liberating their data using AWS Sitewise. Coca-Cola Isotech, or CCI for short, is one of the leading Coca-Cola bottlers in the Coca-Cola system. They're based in Turkey. They have 10,000 employees, 26 sites spread across, mainly around Middle East, Central Asia, Turkey, Pakistan, and other countries in Eastern Europe as well, such as Turkmenistan, Kyrgyzstan, Azerbaijan, and many others. The key goal is to serve, currently they're serving 400 million consumers worldwide, and the key business objective is to improve operational efficiency, environmental sustainability, so they can expand their distribution outlets, as well as increase volume sales and keep costs low. So like many other plants in the CCI network, a lot of their data was collected in a very kind of manual, analog way, and a lot of their processes were tracked by humans as well. So one of the key things that they were looking for is how do they continue to get more operational efficiency by implementing advanced analytic systems around their IoT data and allow them to do get more and more insights in near real time. And for that, they selected Sitewise and Greengrass on the edge. So to start their journey, we started an applied pilot on what they call the cleaning process life cycle. And I'll talk a little bit about that in the next slide. We implemented this process in 3 plants, and we use this, and we deliver this use case in 2 months using Greengrass at the edge and Sitewise in the cloud. We did a number of modeling of their data. We created some near real-time analytics, which they could visualize on their dashboards. And then we started to collect data on their major assets, like mixer machines, filler machines, production lines, packing machines, etc., so they could take that data and start understanding the condition of the assets and start understanding what impact of the condition is to the availability of their machines. And based on the lessons learned around these, they're going to roll out this process across their 26 plants in their enterprise. And Thomas will do a deeper dive on the architecture when we get to the next part of the presentation. So to provide you some context of this pilot, the CIP process, or the clean in place process, is very much a process that cleans the interior surfaces of all your production lines and the tanks that they use to actually create the Coca-Cola beverages. Part of the kind of key around this is that each time they change the flavors, you need to go through this process. You need to make sure that everything's clean. There's no cross-contamination between one plant, one production run and another production run, and make sure that there's kind of sanitization that takes place, across the whole of the plant cycle itself. So if you look at the CIP system itself, which is sitting there in the middle, think about this as a really big washing machine, and it has multiple cycles that have to be run, anything from 10 minutes to 3 hours. And the process takes place with flushing the system out with water, putting more water into the system, taking it up to the right temperature, dissolving all the solids in those interior surfaces, flushing all of that out, then adding more water, and then adding sanitizing chemicals, and then flushing out the water. So as you can see, this is a very energy-intensive and water-intensive process. But by bringing all the relevant data from these different steps into Sitewise, CCI created a baseline that could compare from production line to production line, from plant to plant, and then in near real time, understand if there were any anomalies in that process and address things like water usage or managing the temperature of water at the right step for the right period of time, thus optimizing the energy usage. And by implementing these processes, CCI have kind of recognized some very significant savings. So they've saved 20% of electricity on an annual basis, 9% reduction in water usage, and have added 34 days of production cycle time based on the insights they gained by implementing these digital twins. So where is CCI today in their journey? They've implemented this clean-in-place process in 3 plants on 8 CIP systems. They've expanded their digital twins for filler mixer machines, analytics, so they can identify machine failures and improve production line performance. They're adopting new site-wise features. We launched new features in the middle of the year, this year. They're taking some of those features so they have less reliance on custom code, and they're also optimizing the edge-to-cloud architecture. So as they scale to their 26 sites, they need to understand what can they do at the edge, and what do they need to send to the cloud, and with that, they can reduce cost and also plan for scale as well. And then, in terms of where they are in the future, we're currently working with them to understand what that kind of edge-to-cloud architecture is going to look like for those 26 plants. And we're going to start rolling those out in a phased way in 2022. And in parallel, CCI is developing a roadmap for the next set of digital twins that they want to deploy. And this will further optimize their plant operations and enable them to scale production while reducing cost as well. So, if you knew the state of everything and could reason on top of that data, what problems would you solve? And with that, I'm going to hand over to Thomas, who's going to give us a deeper dive on SiteWise, so you can understand how you can use some of these services to start getting more insights of the data that you guys have. Thomas?
Thank you, Sanjay. So hi, everybody. Good morning. Again, my name is Thomas Cummins. I'm a Senior Partner Solutions Architect at AWS, specializing in IoT. So I generally work with our industrial IoT partners to build these industrial IoT solutions for their customers. And so with that, we'll take a deeper dive on what is AWS IoT SiteWise and how to use it to build these industrial IoT solutions like the one Sanjay just went over for CCI. So we'll do an overview of SiteWise. We'll start looking at some design patterns and other services that you can use in conjunction with AWS IoT SiteWise, including the other IoT services, the AI ML services that we have, and then we'll take a look at the CCI reference architecture and see how it's all brought together for a real customer use case. So what is AWS IoT SiteWise? It is a managed service offered by AWS that allows you to model industrial assets and then ingest, process, store, display, and then consume the data for those assets. And so the idea here is if you have a production facility like what CCI has, or other facilities that are in manufacturing or oil and gas, let's say, you need to have a representation of all your physical assets in the real world, including all the characteristics that define those assets. So the make, the model, the serial number, what time series data is being collected for those assets, so the sensor values, and then what processing you want to do for all that raw data. Perhaps it's not useful to have just the temperature and the pressure of a particular asset. You need to do processing to provide a calibration function for some raw data coming in. Perhaps you want to do some averaging or find the maximum or minimum of a raw data value over a period of time. That is what AWS IoT SiteWise is designed to do. It's designed for customers and partners to build industrial IoT solutions where that is serving as the foundation and the platform to model the industrial assets and then do something with that data and produce insights. And as we'll see with CCI, those insights are directly leading to energy savings and water savings. So what are the components of SiteWise? You have the ability to model the assets. You have the ability to ingest the data. So there's an edge component that runs out in the real world, and then there's a managed cloud service that runs in the AWS cloud. You have the ability to model the assets, ingest the data, process them, and then you can also display them on AWS IoT SiteWise Monitor, a managed service feature that allows you to build dashboards to visualize data. So let's start with the main component here, modeling of assets. What does that mean? So we need to create a digital representation of assets in the real world. And so for here, we'll use an example of a stamping press. Let's take the example of a discrete auto parts manufacturer in one of their production lines. They have these stamping presses that are turning blanks into machined stamped metal parts. And so what a model is in SiteWise is essentially a description of an asset with 4 primary properties. These are attribute properties. These are fixed values. So make, model, serial number, things that don't change but are still descriptive of the asset. And you could even describe asset properties to do things like the maximum allowable pressure of a press line. Things like that are used to actually calculate transforms and metrics, which are other types of properties. The next type is measurement properties. These are the raw time series values that you're gathering for these assets. So these are generally coming off of a SCADA system, PLCs connected to the machines, or IoT smart sensors that are retrofitted directly onto the assets. Those are the raw values. And for this example, the force of the press, the temperature and the vibration, those are the raw values. Those would be measurement properties. Then there's transform properties. These are mathematical and logical operations you're performing on that raw data. So let's say you have the raw press force that you want to calibrate according to some parameters. You can do that with a transform property. So whenever every new press value comes in, you can apply a mathematical formula to produce the calibrated pressure, and you want to be able to save that. And again, all these properties are saved as individual time quality value data points in the managed service of AWS IoT Sitewise. So the raw data is stored and all the process data is stored as well. And then finally, there's metric properties. Very similar to transform properties, but there's a time element. So you're applying some sort of a mathematical or logical operation over a period of time. So we want to find the average pressure force every 5 minutes. That's what you're doing with these transform properties. And so that's the first part of Sitewise, is modeling these industrial assets. So if we have the CCI facility, what they did is they modeled each individual machine within their cleaning in place process using these models and the assets you create from these models in Sitewise. And so the concept of the asset is an instantiation, one or more times, of a model. So the model is the abstract representation, and that we call the stamping press in this example. And if you want to create one or more stamping presses as unique assets that represent assets in the real world in a one-to-one fashion, you would instantiate assets from those models. And so we have models that we define the characteristics, and then you instantiate the models to create assets. Once those are defined, we can start ingesting data for those assets. And this is actually a newly released feature just last week, and it's called Sitewise Data Streams. And this is the ability to ingest time series data for assets without having to create those models and assets ahead of time. And so that's a very subtle difference, but it's very important. What this means is for industrial customers, you can point to where your data is, say on an OPCway server with a Sitewise Edge Gateway, which we'll get into in a minute, and you can immediately start pulling in data and storing that data persistently. At that point, you can then create models and assets that represent your real assets on the plant floor, for example. That stamping press is an example. And then this is the process where you're linking those data streams, which are uniquely identifiable and stored persistently, and you're linking those to the individual assets that you define. So this is it's a new feature released for Sitewise, and allows you to essentially start the journey with a customer immediately and starts bringing that data into Sitewise, and then you can decide how you want to model these assets. And if you want to change those assets, this allows you to do that. So what we're looking at here is actually a screenshot from the actual AWS console for AWS IoT Sitewise. And what you're seeing up here is individual data streams. So this would be an example where there's two different data streams coming into Sitewise. And then we want to, first of all, see that data on a chart. So we can see live data coming in, verify that it's there and it makes sense to us. And the next process is managing the data streams. So with clicking that button right there, what you're essentially doing is saying, okay, I have data streams, and now I want to map them to specific asset properties. And we just went over what measurement properties are. Those are the raw time series data values. So in this example, if we have this hypothetical wind turbine with actual measurement properties like the torque value of the drive shaft of a wind turbine, we have the data streams that are being gathered from the real world and ingested into Sitewise. And this is the process where it's a little hard to see right here, but you're clicking a radio button that's identifying a specific measurement property, and this is the actual data stream that's being associated with it. And then when you click save, essentially, you just bound those two together. And what's interesting here is that's reversible, meaning you can associate data streams to measurement properties, and then you can also disassociate them. So again, this is an example where if you already have a data stream linked to a measurement property, and let's say you have a wind turbine and you want to actually break that wind turbine up into multiple different components, so you need to disassociate a data stream from a property of the main wind turbine and then reassociate it with a child asset, essentially, in a hierarchy. This allows you to do that. So it's giving customers and partners building these solutions flexibility on how you ingest data and how you model assets. These are now decoupled. So you can do both at the time of your choosing, essentially, which is it's a great advancement. Okay, so we've modeled assets. We know how data is coming in terms of how we're mapping it to these properties, but let's look at the different paths the data can actually come in to get into AWS IoT SiteWise in the cloud. So the three main paths right here that we're showing is on the top, devices. So any IoT device out in the real world that can talk MQTT, they can also send messages over HTTPS, but MQTT is the primary protocol used for these IoT devices to send them to AWS IoT Core, one of our managed IoT services. Inside here is a managed MQTT broker that this device is communicating with. The rules engine inside of AWS IoT Core has a rule action that can route these telemetry values directly into SiteWise. So you don't necessarily need a gateway device to bring data into SiteWise. You can have any IoT device out in the real world, and if it's connecting to IoT Core, there's a native feature that routes it directly into SiteWise without having to write custom code. The next path is actually sort of the primary path that we end up working with customers and partners on, and this is through what's called an AWS IoT SiteWise Edge Gateway, and we'll get into more details on what that architecture looks like inside of there. But this is basically connecting to an OPC UA server through its OPC UA client, which is within the Edge Gateway, and pulling data and streaming it directly into SiteWise. So we'll get into more details here, but this is the primary path that we see customers using. And then there's a third path down here, which is the AWS SDK. So you can use the APIs that we have for SiteWise to directly put data into SiteWise. So a third-party application can use this that's already running in, say, AWS, and it wants to put data into SiteWise. It doesn't need to host tags on an OPC UA server. It doesn't need to publish over MQTT. You can just use the SDK, and it's basically making HTTPS post requests to put data into SiteWise. So those are the three different ways you can get data into SiteWise. How would we get data out of it? So let's say, going back to the example, we've modeled that stamping press, we've ingested data, we've actually created some transforms and metrics computed from the raw data. So we have some interesting data here. We think we might have the maximum pressure force that was ever experienced in that by that press, and that's a piece of data that the plant operator needs to know. They need to know the maximum pressure that press experienced. So how do we get the data out of it? This is the time series. Let me go back. This is the time series data store within SiteWise, and so here are the three primary paths to get data out. There's a feature called Asset Property Update Notifications, and what that means is for that stamping press, if any of those raw values changed, or any of the transforms or metrics changed, a message is published to IoT Core, and then you can subscribe to that topic. Or you can route it through the rules engine and send it to anywhere you want. And in this case, we're just showing a generic custom app as the recipient of that data. But the key thing here is this is event-driven. So as soon as any value changes in SiteWise, a message is automatically published to IoT Core, and then you can consume it from there. So there's no cron job you have to set up to check and pull data. It will send it when it changes. The next path is the get query API path. So there's AWS SDK you can use to query data to pull it out of SiteWise. And so you can do things like, for that pressure force of that stamping press, give me the latest value. So we'll return the latest value and the timestamp and the quality. You can get a range of values. So you say from Tuesday to Wednesday of last week, give me all the values for that pressure or the vibration. And then there's interpolated values. And so this is useful if you want to, for example, downsample really dense data. So if you have a presentation layer you've built to visualize data, you don't necessarily need data at 1 second intervals. You maybe only need the data every 1 minute. You can downsample all the data in SiteWise, so it's a much lighter weight query to pull it back to your presentation layer and display. You can also use that feature to interpolate and fill in missing gaps in the data in order to show a more smooth presentation layer. The last piece right here is the data export path to S3. This is relatively new, but this is a native feature, and when you turn it on, it's mirroring all of your data in SiteWise into S3. So this has been a highly requested feature from partners and customers. So to bring data into a data lake, it's not an either and, it's a Oh, it's not an either or, it's an and story now. You can bring data into SiteWise with all your modeled time series data and then join it up with all the other data you have in your data lake in S3, and there's no code you're writing to do that. It executes on a schedule, and the asset data, the metadata, and the time series data itself is all put into S3. Okay, we mentioned AWS IoT SiteWise Monitor earlier. This is a feature within the service that lets you build fully managed dashboards. And so we'll get into, in the next slide here, we'll walk through a very brief demo video of it. But this is the ability to build a dashboard and then have it hosted in the cloud, or you can actually host it locally at the edge through a feature of AWS IoT SiteWise Edge, which we'll get into. And so this allows you to build dashboards, line plots, dot plots, histograms, KPI indicators, apply thresholds and things to see the data. And it's a low-code environment for you to develop these dashboards, and then you can give access to users either through SSO or IAM credentials to your entire organization. So anybody from someone on the plant floor to the CEO can visualize dashboards that are custom built for them. So a plant manager might be seeing a different dashboard than the CEO or the CTO, and that's perfectly fine. And that's the AWS IoT SiteWise Monitor. And just to take a look at what it looks like, you're basically looking at these different widgets. You're selecting different time areas to zoom in, zoom out. You can select different windows to visualize the data. You have control over which widgets you add, and the editing process is what we're going through right here, and you're changing thresholds so you can visualize when data is above or below a certain range. You're changing the types of plots you're seeing. You're adding or subtracting specific properties that you want to see in a dashboard. You're rearranging the size and the shape of these widgets, and again, applying thresholds for data being too high or too low. And that's what you're doing with AWS IoT SiteWise Monitor. This is the editing process for creating dashboards. And once you've created them, you can give access to your different users. Okay, so we've talked about AWS IoT SiteWise in general and focused on the cloud component. And it was launched as a managed cloud service, but there is an edge component. And this is what AWS IoT SiteWise Edge is. It's software that runs at the edge. It's actually running on top of AWS IoT Greengrass, if you're familiar with that service. And its job is to consume data primarily from an OPC UA server and then stream that data into SiteWise. And then this new feature right here actually brings a lot of the features of the cloud down to the edge. So you have a local storage of all your metadata. All of your assets and the asset hierarchy and all those asset properties are now locally accessible at the edge. All the data is stored persistently. So you're obviously limited by the disk space of that physical piece of hardware where you're running AWS IoT SiteWise Edge, but now all of the asset properties that you care about, the raw data, the transforms, the metrics, those are all stored persistently locally. And then you can decide what data you want to send up to the cloud. So maybe you want to send everything. Maybe you need all that raw data into the cloud because you're going to use it to train a machine learning model or run it through a service like Lookout for Equipment, which we'll look at in just a moment. Or maybe you only care about sending those KPIs up and you've calculated, for example, OEE locally at the edge, and you only send those that data up to the cloud to be consumed in a dashboard in SiteWise Monitor or maybe by another application. Okay, so what does edge processing look like with SiteWise Edge? Getting data into it is similar to what we were just talking about. It has a collector, essentially, that's ingesting data over AWS IoT, over OPC UA, and that's coming into SiteWise Edge. Inside of SiteWise Edge, that's where you have, your assets, all the property definitions, all the time series data and the transforms and metrics are stored persistently, and then you can fetch that data through a GET API directly from the edge. So that's a local connection. You're not going to the cloud for that data, which has been a request by several customers. And then you're deciding what data gets sent up to the cloud. Again, you can send everything. You can send only a limited amount. And so that's the flexibility that the SiteWise Edge gives you. Okay, and then looking at what does the architecture look like for this service here. So in the cloud here, this is AWS IoT SiteWise Edge. That's the managed service that we've been talking about. And so here on-prem, what do we have going on? So we have IoT devices. We have OPC UA servers. We potentially have ISV partner applications that do all this industrial protocol translation and then expose data on an OPC UA server. So we work with all these different types of partners. Some customers want to pull data directly from an OPC UA server. Perhaps they want to build their own. The data collector component of AWS IoT Sitewise Gateway is what's ingesting that OPC UA data. And again, this is all running on top of AWS IoT Greengrass. And so this icon up here, Greengrass in the cloud, when you provision a gateway in Sitewise, what it's doing is creating a Greengrass group and core definitions, and then that's what's managing this software that runs at the edge. So you will install software at the edge, that's running on top of Greengrass, and the key piece here is this Sitewise Edge Gateway. That's what's collecting data from OPC UA servers, and then through this publisher component, streaming it to AWS IoT Sitewise. This component is the one that we're talking about when we talk about all that edge capability. So it's called the data processing pack. So when you provision gateways in Sitewise, you have an option to provision this data processing pack. When you click that, that's what gives you all the capabilities to store the data locally, store the asset property data locally, host Sitewise monitor dashboards locally, all that capability. That comes with an additional per monthly cost. If you do not choose that, it's free to use this software. So the default's free. You pay a monthly fee to use that data processing pack for every gateway instance. Okay. So now let's get into some design patterns of using AWS IoT Sitewise, and let's look specifically at other IoT service integrations. And so this is fairly high level here. We're just showing Sitewise in the middle, and then I'm going to walk us through what are some common design patterns of how you integrate with other IoT services and why you would want to do that. A single IoT solution may not need all these services. That's not the point of this slide. This is just a reference architecture slide to show all the IoT services that are out there, and then what the patterns are if you do want to connect with them. So we have Sitewise in the middle. We have the Sitewise Edge Gateway component, which we just went over. And so in this example, maybe it's pulling data from an OPC UA server that's inside a partner's ISV partner edge application. Data's coming into Sitewise, and so what can we do with it? So routing into IoT Core, that's that route of asset property update notification. So event-driven architecture pattern here. Whenever something changes, send a message to IoT Core. From there, you can subscribe to that topic and receive the data, or you can route it through the rules engine and send it to a number of AWS services or an HTTPS endpoint if you want. Down here, this is actually a new service just announced this week at reInvent in public preview. It's called AWS IoT Twin Maker. It's our digital twin building service. And so what you're doing in here is creating representations of physical assets in the real world through what are called entity definitions. And then and that entity could be something like a stamping press, a machine at a bottling plant, physical assets. You give those assets component definitions that are attached to the entity, and this is where you give them the ability to consume data from different places, including from Sitewise, or from a service like TimeStream, or from Kinesis Video Stream. So you have the ability through that Twin Maker service to build a digital twin of an asset or facility, and then link it to wherever the data lives for those assets, whether it's video data, object data in S3, or time series data in TimeStream or Sitewise, and bring it all together, and then build 3D models of those assets, and then link the data to those assets, and do things like when an asset pressure value goes above a threshold, change the color of that asset in that 3D view. So if you're a plant manager and you're seeing 1,000 assets inside your plant, and you're looking at that dashboard, it may be a lot of work to go through a normal telemetry graphs of everything and see what's wrong. But this is the ability to visualize everything in 3D, and then something would change color when the value changes. So ability to basically triage support and responses to events. Up here, AWS IoT Events. So this is our service that helps you respond to alarms, alerts, events, and build state machines, essentially. Inside of Sitewise, for any particular property, whether it's a measurement property, transform, or metric, you can set an alarm, which means you set a threshold value, and when that value gets breached, a message gets sent to IoT Events, and then you can take an action from that. And that could mean taking into consideration other values, or triggering a Lambda function, sending an SNS notification to tell someone to respond to an event, things like that. AWS IoT Analytics in the middle here. So this AWS IoT Sitewise has the ability to have AWS IoT Analytics be the data store for all the data that's exported into S3. Essentially, it's a managed S3 bucket through IoT Analytics. And then from when you have data stores in AWS IoT Analytics, you can query that data store and create data sets. And from there, you can run a notebook off that data set or just visualize the data set directly using a BI tool like Amazon QuickSight. And then the last piece here is the integration with S3. And so this is the new feature I just mentioned, or relatively new feature, where you just turn on this feature and it's exporting all of the property data and all the metadata. And from here, you can have it be part of your data lake. You can visualize the data with QuickSight. You can query it with Athena. As we'll see in the next couple slides, you can train machine learning models with that data once it's in S3. So these are, again, an overview of the integrations with other IoT services that you can use with Sitewise. Okay, and then just going back, this is the one we just went over with the AWS IoT Sitewise Edge data ingest over the OPC-UA path. And so here's a different way to ingest data into Sitewise from the edge using Greengrass. So again, we have Greengrass running here. Greengrass in the cloud, the service is managing that deployment. And so what do we have in the middle or on the far left? We have, say, IoT sensors. These aren't tags that are on an OPC-UA server. They're just maybe third-party sensors that we know can publish data over a custom protocol or, say, MQTT. If it's a custom protocol, it can send it to an endpoint that's essentially hosted inside Greengrass in the form of a custom Lambda function. And then that Lambda function, the code is taking that custom protocol and then converting it into something that makes sense in your own JSON schema. And then it can put that data over the interprocess communication, IPC component, and then have it be subscribed by another custom Lambda that is taking that data and then using what's called the Stream Manager client, which is an SDK that you can use when you write Lambda functions and run them in Greengrass, and stream that up to Sitewise. That Stream Manager client, it's actually what's baked in to the Sitewise Edge gateway. That Sitewise Edge gateway is using that same Stream Manager client to take data and then stream it to AWS IoT Sitewise in the cloud. Another potential pattern is if you have IoT sensors that publish MQTT, but you don't want them connecting to the cloud, you just want them to connect locally, that's what this is. This MQTT bridge component is a native component inside Greengrass. Allows you to connect to this server here, and then you can subscribe through IPC to those same messages and then stream them up to Sitewise through that component. So the code you would be writing here in that case would just be that custom Lambda, basically. That's the code that's taking messages off IPC component and then streaming them to Sitewise using that Stream Manager client, which is, again, an SDK you just use in your code. Okay. Now let's talk a little bit about the AWS ML stack, ML AI stack, and how Sitewise can kind of interact with some of these services. So this is an overview of all the AWS AI ML services arranged in 3 layers. So here we have infrastructure. So these are, AI or ML optimized EC2 instances, for example. The second level here is moving one level up the stack. This is SageMaker, and primarily SageMaker Studio IDE. So this is all these features being added to this IDE to make it easier to take data, to prepare it, to train machine learning models, and then host endpoints. And then up here is the AI services. So these are the furthest up the stack, and they're trying to make it easier for developers, not necessarily data scientists, to be able to use our AI technologies. And so the one we'll be talking about today is the lookout equipment and lookout for metric services. The ability to just hand it data, it will baseline a model for you, train a machine learning model, and then you can send it more data, and it will tell you when there's an anomaly. Things like that, where you don't need a data science team to build it for you. Okay. So let's look at AWS IoT Sitewise and how it can integrate with some of these AI ML services. And we're just going to look at just 3 for now. We're just going to look at SageMaker, Amazon Lookout for Equipment, and Amazon Lookout for Metrics. Otherwise, we'll run out of real estate on this slide here. So here we go, AWS IoT Sitewise on the left. And again, we've modeled our assets, we've ingested data, we've produced some interesting KPIs. But let's say we haven't been able to generate all the insights we want to. We need these AI ML services to do things like look for anomalies. That's what these services down here do. So Amazon Lookout for Equipment, what it does is you feed it time series data for, say, a stamping press has 10 different features right? It has temperature, pressure, a couple different pressure values from different points of the press, vibration. It takes that data and you feed it in the form of an S3 bucket. So if we're using SiteWise and we have all this press data, what we can do is stream it once we train the model, and the way you train the model is you put data into an S3 bucket, and then it will train a model for you. So you're not doing any sort of featured engineering or model optimization. That's what the service is doing. Once this endpoint's available, you just can stream asset property data through IoT Core. It can put it in an S3 bucket, and then on a regular cadence interval, Lookout for Equipment is looking into this S3 bucket, pulling the data in, and again, this is data for the full asset, so all the features, and it will produce an anomaly inference and put it back in an S3 bucket. You can then have like a Lambda be triggered on an S3 event notification to take that data and then put it back in SiteWise as a new property. So you have all your raw data, but then you will have a new property called anomaly score, for example. And that's what that Lambda is writing into SiteWise. And then in SiteWise Monitor, for example, that dashboard building tool, you can have the raw data, and right next to it, you can have the anomaly prediction. And this is where you can start to really leverage the power of the AI ML services with SiteWise. Lookout for Metrics is very similar. It's only looking at a single metric. So we're not looking at multiple properties of an asset. We're looking at the vibration value only. But the pattern's generally the same. You feed it data into an S3 bucket, it's pulling it out of there, and then you can have a Lambda function get the anomaly scores and then put them back into SiteWise. The last one up here is Amazon SageMaker. So the pattern here would be if you have data in SiteWise, you can export it to S3 through that S3 export feature. You can then have the ability to run notebooks, to train custom ML models, and then host endpoints directly in SiteWise. And then when you have new values come in, new property values, you could then stream them through IoT Core using that asset property update notification feature. And then the Lambda function hits the endpoint, gets the inference, and then you can do something with it. For example, write it back into SiteWise as that new property value called, depending on what the ML model does. If it's an anomaly detection model, write it into an anomaly score property. If it's calculating remaining useful life, which is very useful for a predictive maintenance application, you can have a property in SiteWise called remaining useful life, and the values are generated through this inference, and then they're put back in there through the Lambda function. So these are just 3 examples, 3 AI ML services, and then how SiteWise can be used to integrate with them. So the way to think about it is you're modeling your assets in SiteWise. That's where you're ingesting all the raw data. And then for those AI ML inferences, you're using these services to get that value, and then you have a mechanism to put it back into SiteWise. So SiteWise becomes your single source of truth for the asset definitions, and then the actual raw value and the KPIs and telemetry. And then as we talked about, there's multiple ways to ingest data from or pull data out of SiteWise. If you have your own custom dashboard that you want to use, you can keep using that. You just use SiteWise for what it's good for, which is modeling assets and then ingesting, processing, and storing the data for those assets. Okay, so we've kind of gone over what is SiteWise, what are some design patterns with it, how to integrate with IoT services, how to integrate with AI ML services. Now let's take a look at the CCI use case here. So before we dive into the architecture, let's remember the most important thing is CCI wanted a business outcome. They wanted that 20% energy savings and that 9% reduction in water. That's the true north of what that project was about. And so how do they get that? They get that by optimizing that clean in place process. And what does that mean? That means don't run the water flushing step for 1 minute more than you have to. Run it for the exact precise amount that you need to meet all the requirements, and then don't waste water, don't waste energy. And that just comes down to their experience. They know what it takes to run these plants, but there's so much data. That's what SiteWise is good at, is modeling all of those assets, every single machine in that cleaning in place process, ingesting all the raw data from it, producing those KPIs that they need, and then allowing someone to sit down on the right-hand side here and be able to look at knowing exactly how long each step took and how long it should take, and then knowing how to optimize their machines in order to save that water and save that energy. So what does it look like? So on the right-hand side, we have the cloud, the AWS cloud with SiteWise. On the left-hand side is their on-prem environment. And so they're gathering data on their OPC Waste servers already from their machines. So this is a common use case where they have that data, but it's not in a form where they can get the insights out of it. So they're ingesting data from an OPC UA server through the SiteWise component of Greengrass. It streams into SiteWise. SiteWise is where they're modeling all their assets. Every machine in that cleaning in place process is modeled here. And then this is the current architecture where they're essentially computing some metrics, but then using Lambda and DynamoDB and IoT Analytics to compute other metrics that they need, including optimal, like the start and stop times of each process, for example. And then they're putting that all into an S3 bucket where they can visualize it with Amazon Athena and QuickSight. And then they have an interest in training machine learning models to see, solve future problems like predictive maintenance, for example. When are these machines going to fail? What they're looking to do, the evolution of this project, and this is ongoing right now, is they're looking to use that AWS IoT SiteWise Edge gateway, and specifically that data processing pack. So ingest the OPC UA data through the OPC UA data collector, but then use that data processing pack to process and store that data locally, and then actually host that SiteWise Monitor dashboard locally so they can visualize the data without any data leaving their plant to start, and then they can sync all the data they want up to SiteWise. So to start, that will be the raw data as well, because they want to make that raw data available in S3 as well, like we talked about that S3 expert feature, so that they can train their machine learning models with that data once it's in S3. And so this is the future path they're going to. Again, they model the assets in SiteWise. The data is collected. It's already existing on their plant floor, but this data, this SiteWise Edge Gateway gives them the ability to easily stream it into SiteWise, and then they're producing those insights using those transforms and metrics within SiteWise, and then putting all the data into S3 so it can be visualized. And again, their goal is to optimize their energy and water consumption, usage and consumption, respectively. And this service, AWS IoT SiteWise, is that platform service that you're using to build this solution. Okay, so let's talk about how you can get started with AWS IoT SiteWise, or even dive deeper if you've already gotten started. So here's some technical resources that you can look into. So with AWS IoT SiteWise, the developer user guide, great resource to start going through. AWS IoT SiteWise, the console demo. So when you're in AWS console, and you go to AWS IoT SiteWise, there is a demo you can run directly from that home screen of the console. That's a demo wind farm example. So I suggest you start that right away, because it will launch a CloudFormation stack automatically. It gets up and running in about 5 minutes. You can tell it to run for up to 7 days, and then it'll clean everything up for you, so this won't run forever. And you can immediately start seeing how you ingest data, start playing around with building transform properties, building metrics, building dashboards, playing around with those data streams, associate data streams to two particular properties, disassociate them, and then rearrange them. It's a great way to get started really quickly. There's a public workshop, AWS IoT workshop. If you see that, just copy the URL down here. Deeper dive on building stuff from scratch. So the demo that right here gets it started immediately. The workshop lets you build everything yourself, which is always the best way to learn. Some resources with AWS IoT Greengrass, especially Stream Manager. So that's that client that's taking data at the edge and then streaming it into a number of services, actually, one of them being SiteWise, which is what we talked about today. And then here's the AI ML services that we talked about. Look out for equipment. So it's looking for anomalies in equipment. Look out for metrics. It's looking for anomalies with a single metric. So vibration, for example. It's looking for anomalies with that. And then SageMaker. Partner offerings. So AWS partner solutions are listed here, so copy that URL down, and you can see ISVs, SI, GSI partners that have IoT solutions, including industrial IoT solutions that you can go use. And then there's a AWS partner device catalog. So if you're thinking of developing a solution and you're saying, we don't have hardware, we don't have sensors or gateway devices, cameras to run computer vision applications, this is a catalog of all of our qualified devices that work with our IoT services. And so with that, I'm going to hand it back to Sanjay here to wrap us up.
Great, thank you, Thomas. So as a kind of quick call to action, I've been involved in a number of kind of industrial digital transformation projects, and I wanted to leave you some kind of thoughts that I have in terms of how you get started. So one of the key things is, how do you get started and how do you make sure that you can get going quickly? So one of the key things around the digital transformation that we're seeing in the industrial world is you need to start to kind of act quickly and typically without the depth of analysis that you need when you do a typical project. And the cloud will help you here because it'll allow you to do some experimentation, and if you think it's going to work for you, you adopt it. If you don't, you move on, and there's no significant investment that you lose in this. As you start developing your digital transformation strategy, make sure that you also talk about data and have a data strategy behind it as well. The two have to go very intertwined. You need to make sure that you understand where your data is, and typically what we find is you already have all the data you need. You typically don't need to add more data to do digital transformation. It's just liberating the data that you already have. And then think about the teams that you have. Make sure you have a mix of pragmatists, people who understand the industrial processes, but also dreamers, people who think about the art of the possible. You want to have people who are going to challenge the status quo. Industrial world is kind of very slow to move. We need people to kind of think out of the box, and that's where you'll start getting true transformation in your projects. And then experimentation. Experimentation is not only necessary, it's also it's a key to your success as well. And you can set up your hypothesis, you can experiment with them, you can do that in a very inexpensive way in the cloud. For example, when you go to AWS services, you can try some of these services out for 30 days, so you don't have to kind of invest a significant amount of money to kind of make that happen. And then think about the partnerships. The people that you partner with have to have the same North Star that you have, and make significant investments in industrial IoT services as well. So that's one of the things at AWS, and part of the reason I joined AWS was I see AWS really investing in that industrial space. So make sure you pick partners that have that same kind of investment as well as you move forward. So as I always tell my customers, think big, start small, and move fast. And with that, I'd like to kind of thank you for your time. And if there's any questions that you have, any feedback, anything that you need clarification, we're happy to take questions at this point.